Hey, welcome to today's session. So today we'll be talking about linear functions. So I asked you to give me a story of what you think about when you think linear functions, or just like a personal story of what you do in your day-to-day activities that you think will kind of mimic this model for linear functions. And you mentioned the story about babysitting. You told me you babysit like 3 times a week on Mondays and Wednesdays and Saturdays. And for each time you babysit, you get paid a certain amount of money. So I put that data in like a T table representing the hours worked in form of our one variable, and then the money you get paid in terms to be our other variable. So later on, we can call the hours like the X, and then we'll call the amount you get paid Y. And that will all come together when when we move on to actually like creating this function and putting it into a formal representation called the slope-intercept form, which is really this form right here of y equals mx plus b. So you might be wondering, like, how on earth do we go from just the hours that I work to how much I get paid to creating an equation called slope-intercept form? So where does that word even come from? Well, the m represents the slope, which is really the rate of change, which is a question of for each change in x, for each change in the hours you work, what is the change in y, the amount you get paid? And for linear functions, we want to make sure, or something to look out for, is that if that change is constant from like these two data sets to these two data sets, then wonderful. It satisfies the criteria to have a linear function. And if the rate of change is not constant, then we have a different kind of function, either exponential or another type of function. Okay, so then we have this equation. We need a slope for m, and for the b part, that's just like what will give us the y-intercept. Okay, so then how do we find the slope? The slope is literally the rate of change. So what is the change in x for each change that we have in y? So, we just go ahead and define our y's here and our x here. So we have y1, y2, and then x1, x2. And if we take the difference in the y's, so 20 minus 40, and then we take the difference in our x's, we get that our rate, and then do the arithmetic, the negative cancels out. So we end up getting a rate of change of 10. But then how do we define this in terms of our context of babysitting and getting paid? Well, this just means for every hour you work, you get paid $10. Isn't that true? Yeah, that's the rate here. Awesome. So, and then after getting our rate of change, we still have something that's not finished here, this b part. And we're like, okay, how do we find b? Well, literally just choose any data or any pair from our table here. We can choose 1 and 10 or 4 and 40 or 2 and 20. Plug it in for the y and for the x, and we isolate for b, and that will enable us to find what b is. So for instance, if we take data set 4 and 40, that means we're plugging in for our y. What are we plugging in? Yeah, that's the 40. 40 equals 10, and then our x is represented by what goes together with the 40. They are horizontally lined up with the 4. Plug in our 4 right there, plus b, and then let's isolate to find what b is. So b will end up being 0. Okay, so then we can formally write the slope-intercept form in terms of y equals 10x plus 0. And simply what this means is that I don't know, if one day I work like 10 hours and I've never worked 10 hours before, well, we decided to give the x variable to the hours. So if I ever work like 10 hours or 11 hours one day and I have no idea how much I need to take home on my paycheck, like my boss asked me, how much do I need to give you today? Well, just take this equation, plug in your number of hours that you've worked, and that will give you the result, which is the y. And in this case, the y is interpreted as how much money you need to take home, because that's the y variable as we've defined it before. So I hope this helps. And then don't, like, sometimes you might be presented with a form that's like for a different equation but of the same slope and forms. It might be presented like 3y plus x equals 4. Don't be scared, because it's the same form. Like, we have an x, we have a y, we have a constant. So what you need to do is simply rearrange this to match the form. Y equals mx plus b. So isolate for y. So what we need to do is subtract x from both sides, and we end up with 3y equals negative x plus 4. And now we need the form y equals mx plus b. Remember that? Y equals mx plus b. And then, okay, let's see what other arithmetic we need to do. So we probably need to divide both sides by 3, which ends up giving us y equals negative 1/3 x plus 4/3. And that's how we do it.